Hello, everybody. Welcome to our second season of Ubuntu Testing Days. So, Kyle, did you think that we would have made it this far?
Well, I mean, technically we took like a month and a half off, so I'm not sure if this far is...
You shouldn't have mentioned that. But, okay, so I'm Leo Arias. I'm QA engineer in Ubuntu, and we're making these testing days to help new people join the Ubuntu community. We show some cool projects, and we talk here to the developers of those projects. They will tell us where they need a hand and some of their work in progress. So let me introduce you to our guests. First, Kyle Fasari. Please say hi, Kyle.
Hey, I'm Kyle Fasari. I am on the Snapcraft team, so most of my duties, kind of focus on Snapcraft itself and the Snap developer experience. Federico, you want to go next?
Sure. My name is Federico Jimenez. I work as a QA engineer in the Snapd team. Mostly I'm concerned in quality affairs and making sure that all the required features for the product get to the users in the best shape possible. Well, more or less that's it. And next, Michael, want to go?
Sure. Hello. My name is Michael Vogt. I work as a software engineer on the Snapd project. Yeah, that's it.
Okay, I can say hi as well. Hi, I'm Zygmunt Kudnicki. I'm Zyga, and I work in Snapd as well. I'm mostly working on Snap and Fine and those bits related to interfaces. Yeah, that's it.
Well, and of particular interest to, where people can contribute, you're also kind of the main contact point for cross-distro support, right?
Yes. Although lately, that's I wish I had a little bit more time to spend on that. I'm specifically working on one thing before I move over and refocus on cross-distro, and just polishing and finishing, bug fixes on the content interface that many people, would like to use. So, as soon as that's done, I'm going to switch back. And there's ongoing work to make sure that Debian is under CI, and that all, we can pass all the tests in Debian. There's renewed interest in CentOS. There's renewed interest in OpenSUSE. So there's a lot of cool stuff coming. It's just I cannot focus on 100% just yet.
Oh, there's only so much time. Yeah, which is one of the reasons you could use some help.
Absolutely.
It's great you joined us, Zyga. I'm sorry about that. I'm from Costa Rica, a place known for the beautiful beaches and the terrible network connection. So I might drop every now and then. So everybody said hi already?
Except for our Lenaro guest.
Okay, let's go with Robert.
Yeah, hi everyone. My name is Robert Wolf, and yeah, I work for 96 boards in Lenaro. This isn't necessarily with Ubuntu or anything, but we do have a great platform that runs the Ubuntu Core images, and in particular on our Dragon Board 410C, which I've been told is the reference platform for Ubuntu Core on the
ARM64. Yeah.
Great. Yeah. So 96 boards. It's number 96boards.org, and it's basically a SoC agnostic single board computer that you can kind of see a few of them back here. We're going to be doing a nice show, I think, next week, talking a little bit more about it. So I don't want to go into too much detail, but you can read more up until next week's episode on the 96boards.org website if you're interested.
Okay, thank you, Robert. Yes, we will be making a lot of shows together. Some interesting things coming from 96 boards and Ubuntu Core, especially next week's show, but we will talk about it at the end. Do you guys see MBO? I see it. I see him.
Yes, he's
yes,
here.
he's here.
Okay. So Michael, can you say hi, please?
Oh, hello again.
he did.
Yeah, I introduced myself before.
We're all good now.
Okay. Sorry, Michael. We wanted you to show us about Ubuntu Core, make an introduction of what this new operating system is. What's the difference with Ubuntu Classic? Can you start?
Sure. So Ubuntu Core is a flavor of Ubuntu that is that has some unique properties that make it different from what we call classic Ubuntu. So Ubuntu Core is built based on snaps, and snap packages are, most people are aware by now, but I will still introduce it a little bit. So snap packages are a new flavor of packaging, a new way of packaging. It's in a lot of ways similar to like if you need to conceptualize it, it's conceptualize it as a deb package, but it has some nice properties. Like for example, it is relocatable by default. It is easier to package. It has a security sandbox around it that can be extended via interfaces. It does by default bundle dependencies, which is nice because it means you will not have dependency hell basically. Like you will never be in a situation where two libraries are conflicting and you cannot install either one application or the other. It's also transactional in the sense that like you cannot break your application or your package, your snap, when you install it, because like either one is active or the other. There is no in-between state, like the switch is happening more or less atomic. I mean, as atomic as you can do it on a computer. And Ubuntu Core, so snaps are available on Classic as well, which is nice because it means that on your regular Ubuntu system, you can just install LibreOffice as a snap and you get the latest LibreOffice. And we also deliberately made sure that snaps are developed at the speed that upstream wants it to be developed. Like upstream can decide, I want the latest OpenOffice in, for example, the stable channel. So snaps have a concept of channels, so stable, candidate, beta, and edge. So a developer can put, for example, LibreOffice into the stable version into the stable channel, but the developer, he or she, can also encourage people to test the beta version or even the edge, the daily build version. So all of this is nice on a classic system, but it's even nicer once you go into Ubuntu Core land, because Ubuntu Core is a Linux system based on snaps. So you have no legacy packages, and literally your system boots from 3 files. Like you have the kernel, you have your gadget, which defines your system, and you have the OS. I mean, to me, this is just mind-blowing. Like if you think about it, like it's literally 3 files, and grub loads the kernel out of snaps internally use squashfs, and so grub loads a squashfs file, picks the kernel, boots the kernel. The init.id loads a squashfs file, the core, the OS snap, sets up the user land, continues booting, and the gadget kind of ties it together. So it's 3 files in the file system. And then, of course, then things get a little bit messy because that's how the real world is. So you have a bunch of files in etc that you can modify and so on. But I mean, like I said, like conceptually, it's all you need to do. And every time you update your system, you download a full snap, a new kernel snap, a new OS snap, and then your switch happens in a transactional way, which again means like if your power cuts in the middle of your update, it doesn't matter. Like you boot and it picks up at the same point where it left. Like you can never be in a situation where your system becomes unbootable because half of your kernel got installed and the other half didn't, or your init ramfs didn't get regenerated, which is rare, but it happens on real systems, on classic systems. This happens, and if you think about it, like you want to have, I don't know, millions and millions of users. So even if the chance is 1 to 1 million that such an event happens, it does happen every day because we have so many users. So we really want to have a system in place that is much more robust.
Well, and ignoring the number of users we have today, if you think of, the market of routers and these headless devices that need to be able to always run while being updatable, this type of, compare it to running a system like that based on devs, or really anything else.
Yeah, that's a really good point, Kyle. I mean, yeah, it's exactly this. So, and thanks for bringing it up, because like what's the reality nowadays? Like a lot of people are super scared to update their system. Like manufacturers, like they ask us like, oh no, we don't want updates, right? Because their mental model is updates break all the time, and we want to change this. We want the internet to be a safer place. We want all these devices, routers, machines, whatever, to be up to date and not have I don't know, dirty cow kind of bugs because nobody wants to patch the kernel and all these other problems. And that's why I think Ubuntu Core is exciting and cool. And just one more. I know I'm waffling a little bit, but so one more thing about the transactionality. Like we even have a thing where if your kernel breaks, it will automatically reboot into your last good kernel, and the same for your OS. If it fails to boot, it will automatically jump back to your good OS or your good kernel. All right.
So when you say if your kernel fails, do you mean if it fails to boot?
Yes.
Okay.
So if, for example, you have a kernel panic at boot, it will like we set it to reboot on panic, and the bootloader has some special logic where it basically puts the boot into a try boot mode, and if it notices it tried to boot a kernel and this kernel didn't successfully boot, it will revert to the previous good kernel, and it will also like on the system level you see your kernel failed to boot basically, and the same for the OS. Like if your OS for whatever reason doesn't complete the boot, it will just go back to the previous good version.
And then it marks that revision is bad. Is that right?
Yes, I think it's not implemented right now as broken, but conceptually we have the state called broken, and this is what it is designed for.
And then it would jump to the next update. Is that right?
We blacklist it basically. Like we make sure we never try this version again unless the user explicitly asks for it. Like it may happen, and the user can, of course, if he says, I want to update to this specific revision, we allow it. But by default, we always skip this version, and we of course try the next one. Like if there's a new revision after that one, we try it, but the same logic applies. If that fails,
I was curious how updates worked after something failed like that. And that applies to all snaps, not just the kernel, right? I mean, because you can have regular snaps fail as well.
Exactly, like conceptually. Like, so we have this system called health checks, but it's not implemented yet. But it's exactly the same system applied to applications. So the basic idea is, as a software vendor, you can basically add a health check to your package. And this may be, for example, like if you have a web app, or I don't know, a Django application. It could be a small curl-based script that just goes over your site and checks if your welcome screen is okay, if you can click on various things, and if it's all okay. And then this health check will report to Snappy, I'm good, and then it's all good. And if not, it will revert the version. And you can always manually revert a version, and you can always manually move forward a version. And this is also a nice property. Downgrades, for example, work generally.
Well, you can get something similar to that today just by using the configure hook, right?
Oh yes, exactly. Like that's a very good point.
I didn't mean to derail that. So snaps snaps contain some hooks that can run at predefined times, right? So snapd is a daemon that is the thing that mounts and runs services out of snaps, and it can run hooks contained inside snaps to notify them of various events. One of them is a configure hook, which runs at what? Install, update, and snap set, right? So for setting configurations. If I return non-zero in the configure hook, it does roll back like on an initial install. Will that revision be marked as bad, or is that not quite the same?
I think we are not marking it as bad currently. I will double check. That might be actually a bug, because I think we should mark as bad probably.
And I mean, obviously that's outside of the health check system.
Yeah.
I was just curious how that worked.
Yeah, health checks are coming soon. I think it's like we are really close, because like you said, the configure system is already very close to it can be used as a health check, basically. We just health checks would add a bit more semantic to it.
So, Michael, we invited you precisely to discuss all these topics. So don't feel bad about talking too much. That's what we wanted to hear you.
Okay.
We just want to leave a space at the end for Federico to show us all these things you have talked about in a real scenario, a real case that people can test, try, and this is pretty much work in progress. A lot of things are stable, but we have a lot of new cool features coming. So it would be great to get people trying that. But before we go there, I have a question for you. On this session, we wanted to talk about Ubuntu Core in QEMU. That's the PC model, but there are other types of models, and you talked about three different snaps. So next week, we will be talking about Ubuntu Core in a prototype board, the Dragon board 410C. So what changes between the PC model that we will be showing today and the prototype board model that we will have next week?
So I guess your prototype model next week will be a self-signed one, right?
We can use the official one. We can
okay.
use we can create one, right? That's an interesting thing to discuss too.
Yeah. Actually, I mean, Ubuntu Core is quite similar, whether you run it on an ARM device or on an AMD 64 device. It feels similar, and that's a good thing, right? Because it means in your QEMU, for example, you can prepare your code and then run it on a Pi 2, for example, on a Dragon board. Of course, you need to cross-compile if you want to, or or compile it on a device, which is also nice. I mean, what we have is like if you don't want to cross-compile your stuff, you can use a Ubuntu Core Dragon board, for example, and then you install the Classic snap, and then Classic gives you an environment that is exactly like Ubuntu. Like you have apt, you have dpackage, you can install whatever you want, like a native GCC, and then, for example, you can compile all your C code directly on your Dragon board. But yeah, I guess that's not really answering your question. The differences between the different models are relatively small. Like the Pi 2 has some more interfaces when it comes to pins, like I/O ports, for example. But I need to look into the details. I don't remember exactly what the name of the pins is. I think it's exactly the same names as the official documentation for the Pi 2.
Right, but then
GPIO stuff.
The core is the same. Well, sometimes you compile it for other architecture, but it's the same source code for everything, for every platform that we will support. Yes,
correct.
And
which is a feature, which is really nice.
Yeah, as you said, it's mind-blowing. Like it even has opened the possibility of running in other distros. That's something that Siga mentioned earlier when he was introducing himself. But in that case, it's the same, right? We have the same Ubuntu Core. It's just that it runs in Fedora, or it will run on CentOS, or things like that.
Yeah, there are a couple of interesting things I wanted to mention earlier. Just I don't want to interrupt, guys. There's something that's super obvious, and we keep forgetting how amazing this is that we did when we designed Ubuntu Core, is that the core snap is exactly the same. And if one vendor makes a device, you have a router, and just never updates anything, right? Just you slap some software on it that makes it a router, and just has all the other snaps are the same. And some other vendor really pays attention and makes super careful updates and pays attention to all the details. Even the lousy vendor will, because they can't really change the core snap, you will get updates for that always, and that's fantastic. So like on the Android where
excellent point.
Either you have an up-to-date ROM or you have nothing. Right here, the core snap will always be up to date. That's utterly amazing. It's mind-blowing how different this is in an industry that just is fears updates. That updates cost money, do updates for 6 months, and they abandon stuff. I think this is fantastic. We should keep reminding ourselves that this is a good design choice. So there's another thing that's really cool, and I think something we're essentially going to start working on, next week maybe even. We keep calling the Ubuntu Core. It's like the snap that puts the basic runtime around your system. This gives you a root file system. Your applications show up inside that root file system. But we've been for a while now, we've been discussing ever since The Hague, the spin of The Hague, I guess. We're discussing the concept of base snaps, which essentially split this world again. So the core snap will just be enough to run snapd itself, right? And the base snaps will allow you to create a distribution of like bootstrap a basic Debian system and put a Debian-based snap next to, at the same time, next to an Ubuntu-based snap or maybe a CentOS-based snap. And all of those snaps can provide the basic file system. If a given application is designed to run in an RPM-based environment, right? You have all those, the file system looks different. There are a couple of different quirks in here and there. You can have all of those base snaps installed at the same time, and the application, decides which base snap it's going to run on. This is also fantastic for transitions. Right now we're on the Series 16, so essentially Ubuntu System 4 is the base for all of this. But we're going to do 18, and we're going to do 20, and so on. But you also be able to have multiple of those. So maybe we have a system that has this application that works really great, next to the base 16 snap. Well, it's 2018, and you maybe want to update all of that. But you're going to be able to keep that application running on top of that 16 base snap. I think this is another fantastic design choice, as we're gonna go through the process of making the core snap splitting into the core and base, and finishing all of these details, fixing bugs that makes all of this work. But once we have that, we're gonna have a nice way to transition to big changes, totally maybe incompatible changes. You're gonna have to consciously transition your application from one base snap to another, and also allowing all of those distributions to essentially work on one system at runtime. That's really amazing.
Yeah, that's really interesting. Thanks for that information. The core snap then will be essentially just snapd. Is that the idea?
I think it will be a small. All of those snaps give you a root file system. All of those base snaps give you a root file system, because then some process can live in that file system and run. Snappy uses namespaces, and so all of those things can run in a different different box on the same hardware. So I think the core snap will still have a base file system in which snapd itself will run, and there maybe going to be systemd in it as well. Some details are sketchy. We're still designing this, but the next, maybe there's going to be a Debian file system that's going to be easy to build as a prototype, right? That can have a different layout. Maybe it's going to have merged users, so /user lib will be a symlink to /lib or something like that. Maybe the other way around. But my point is that you can have them at the same time. And when you start a new application, the application is going to start in that box, right? And you can freely experiment. Someone's going to build a Yocto file system or a builder or whatever that is. You can just essentially spawn these application hosts that will Slacker, yes, that will be completely different from one another, and they will not, stump over each other or cause issues. So I think this is really, really interesting when you think about, what kind of possibility it gives you. You have a basic platform, you got a device that works, the kernel that works, and you have some base file system. You create your dev environment there, and they all these different distributions. You can experiment with all kinds of combinations that are, maybe one of them is going to be suitable for a product, and and you can do this all within one playground. Everyone plays, in the same spot.
Great. I just love all this work that you guys are doing. What do you say if we now jump to Federico so he show us precisely this in a real machine, how it looks running? And well, remember
and when
that
he says real, he means QEMU?
Yes, real but virtual. So remember that this thing that we're doing here is to help testing the stuff, everything that MBO and SIGA talked about. We need a lot of hands to test this, and we need to push it to the millions and millions of Ubuntu users out there. So it needs to be safe. On previous sessions, we talked about Ubuntu Classic, how to make an image, how to put it in a virtual machine. If you are new to these shows, you will see the link on the YouTube description. And we usually make a summary of all the things that we discuss. So it would be good if you go back and take a look at that, and we will make a summary of this one pretty soon after we finish. So what Federico is going to show us is similar to that, but instead of an Ubuntu Classic image, we will be making an Ubuntu Core image that will be composed of these 3 snaps that MPO told us, and it will expose you to all these cool features that SIGA so excitedly talks about. We are really happy about this. So you go, Federico.
Yes, thank you. Well, let me share my screen. Here it is. So we are, as Leo mentioned, we are using QEMU for testing all these Ubuntu Core systems, and now for 2 of the supported platforms, the AMD64 and i386. Previously we used cloud-based images, but right now we are just using those for validating both the fundamental snaps and also the generated images. Now we are going to generate one image by ourselves. For that we are going to use the Ubuntu image tool. It's distributed as a snap, so we can do all this process in any of the distros where Snapd can be installed. I'm using Ubuntu 16.10 for this, but any of the distros could be used. So the first thing to do would be to install.
Federico, can you please make your terminal bigger?
Bigger, it's maximized.
The text.
Of course.
Control plus or something.
Let me check. Something like this.
Yes, control shift plus, I think.
Yeah, that's okay.
A little more.
Like this.
I think that's all right for me. Do the rest of you see it okay?
Yeah, it looks good for me.
Great.
Okay. Well, let's install then the Ubuntu image snap. The current version that we are using, it's in the beta channel. I'm not sure if it has been already promoted. So we specify here the channel to be used, and also we install it in dev mode because it needs to access some of the resources in the host. So we specify here to dev mode and to image.
Now, while this downloads, is there a reason we're using beta instead of stable?
I'm not sure. I'm not sure if it's already promoted. Perhaps we can use already a stable, but
I think stable would require confinement, and we should probably need to figure out which interfaces are missing.
Yeah. Remember that this is testing day. We are all agreeing to a lot of risks. So, yeah, this is really interesting. Of snaps that I think wasn't mentioned. They have 4 channels with 4 different risks levels. So there's Edge, which is for really brave people out there, but it's great to get really early feedback. And there's Beta, because Federico doesn't want this demo to just blow up suddenly, so he's being a little cautious. And there's Candidate, it's almost ready, just the final touches. And then Stable, hopefully it will be good for everybody, but if it's not, it will be rolled back to the previous version, as Michael explained. Sorry, Federico.
No problem. Thank you. Once that we have, let's see if it's correctly installed. Here it is. It's working. Here in the help, you can see that it's used this tool for generating a bootable disk image, and here we see that we need to call it, giving it a model assertion. This model assertion, as all the assertion, is a signed text file, and concretely the model assertions convey some information about the image that is going to be generated. It has info about the architecture, the default snaps to be used, and so on. We could generate, as Leo mentioned before, one model with a JSON file and sign it by ourselves. But for this demo, we can use the official, the canonical models. And there's a command in the snap command line tool that is used to describe assertions, noun assertions. It's called noun. With this command shows noun assertions.
Can you hide the Google Hangouts is sharing your screen
course.
thing? Yeah, thank you.
Of course. I thought I was the only one seeing that. Thank you. Well, with this snap noun command, we can show the noun assertions for the system. It has one option here, the remote option, that allows us to download assertions from the store. So we are going to get the official assertion for the ND64 model. I think that I have this in the story. Yes, this is the command. We use here remote to download from the store. We say what kind of assertion we are going to download, and then some headers for selecting which assertion are we going to download. There is signal, the last LTS, the model that we are going to fetch, and then which is the brand ID or store account store account that is going to sign this assertion, and we are going to save it in this file. So executing this, let's make better the course.
Okay, if somebody is looking at the screen and has a hard time following, don't worry, just listen to Federico. And there's a cool new resource that we have in tutorials.ubuntu.com. There's one tutorial precisely about creating an Ubuntu image that explains more of this. And we will also give you some quick instructions to get you started testing this thing.
So at this point, we should have here the model assertion. This is how it looks like. It has here some information about the assertion itself, and also some specifics, pieces of info about the model, the architecture, which default fundamental snaps are going to be used, the kernel, the gadget, and so on. And with this in place, we can generate the image. I have the command also.
Now, so if I wanted to do this, if I wanted to make my own model, I would have to sign it myself. Is that you mentioned something about that?
Yeah.
Sorry, go ahead.
Yeah, for that you need first to generate one JSON file with this same information, and then sign it with one of the keys that are registered in your account. One of those.
In what account? The SS, like the SSO account?
That's right. I was going to talk about this later, but
then please feel free to continue. I don't mean to derail you. I have not done this, so I'm asking for myself.
This is no problem. This is how one JSON for doing that would look like. This is an unsigned model. And then you need to register one key in your SSO account, and then you can sign this model and get something like this with a signature and all these things. Well, the command for generating the image would be this one. It must be executed by root, and in this case we specify the image size because for the images that are going to be run in QEMU, we need this size. But for other platforms, the image is going to resize by itself. The default size is very small. But in the case of AMD64 and i386, we need to specify the size, because if not, the default size is not enough. We also specify here the channel from which we are going to download the three fundamental snaps. And then the name of the image file and the model to be used. So with this, probably this is going to take a little bit longer, because here it's fetching those three files that Michael mentioned, the core, kernel, and gadget snap, and this is going to be a little bit longer.
This is interesting. The core snap that it's downloading, it's only 70 megabytes, so it's small. It's like the base operating system, but it's not big at all.
Yeah, it has all the OS part of the system. As you can see, it's already downloaded, and this is going to be even tinier, according to what Sigmund previously said, with the separation of the core and base snap for each of the systems. So this core snap includes the file system, but well, it's not too much. It's not too big.
Okay, now it's downloading Linux, right?
That's right.
A little bigger.
The kernel, but not so much.
And another cool feature that's about to land is Delta uploads, Delta downloads. So the first time you download the kernel, it will be, well, you have to download the full thing. But when you have it installed and a new kernel is pushed, you will download only the difference, right?
That's right. Yeah. I think that in this, I'm not sure about the changes in the store side, but I think that the Delta downloads have already landed in the Snappy side. I'm not sure. Perhaps Michael can.
Yes, it landed a couple of days ago. So the feature itself is available since at least 1 or 2 releases, and if you set this snapd _use_deltas_experimental=1 in your etc environment, and you need xdelta3, the deb package installed on your system, on your classic system, then you will get Delta downloads today, and you can have testing, right?
Right. And it has an experimental flag. It sounds fun.
Well, this already finished. We should have here.
Before we continue, so we've explained the core and the kernel snaps, which I think make a lot of sense. Can someone give a brief overview of what this gadget is?
I think gadget is the mysterious snap that no one knows what it does, except if you look at it, because the name is such like, what is a gadget? I don't know. But if you look at what's inside, I think that's easier to follow. Right now, it's just mostly the bootloader snap and a way to predefine something like I have the serial port and it's called foo and it's right here. That's the device node and stuff like that. I think over time, there's going to be more things that are going to be device specific. It's essentially the place we want to put device specific things. Maybe your device has some special way to flash some extra chip on the board, and or you need some special permissions to perform board level activities. But it's not like you don't maybe need a new kernel. You can use a stock kernel from someone else, and you can't have your own custom core snap. So this is if you want to make a new device, this is the identity of your device. It's how it differs from all the other devices. Maybe you build a device that is built on top of a reference platform. Maybe a Raspberry Pi, and put a nice enclosure on top, call it something else. But you don't want to think that this is a Raspberry Pi when you're working on it. You want it to feel your brand's product, Inc., right? Whatever. So this is essentially what the gadget snap lets you do. It lets you give it this device identity, some kind of identity, define some glue code between, this is maybe you need the snap reinstalled, and maybe it has to have connection to this interface. So all of that is going to fall into the responsibility of the gadget snap. Not all of that is implemented today, but that's the essential idea. That's why the gadget snap is with us for all this time. And as I mentioned, also it's essential for booting.
We talked earlier about how on the Raspberry Pi we have a couple of interfaces for GPIO, for example. That is implemented via the gadget. Is that correct, or is that core specific?
Yes, so it is implemented through the gadget. So the kernel is the stock kernel for the Raspberry Pi, and it has all those features that devices have. But for instance, the Raspberry Pi has this fancy pin connector when you have GPIOs, I2C, ESPIs, and all the other embedded interfaces exposed. And typically, on the system, they're like, dev, SPI, I3C1 or something. I don't know. It's just like, I don't know what this is. If you're familiar with a Raspberry Pi, you don't want to, GPI number 25, whatever that is. You want to look at the pin as it exists on your device. That's all the community references it. So the gadget snap just declares that there's a pin, there's a GPIO pin. All the interfaces have like a type, which is essentially the interface. And maybe this is a GPIO pin, maybe this is an I2C connector, and essentially you can give them a name, right? This is like I can call it the blue LED or whatever. And then I can describe what this blue LED is in the system, and I can expose this as static information that Snap will pick up. So when you log into this device and type Snap interfaces to see what you have, you will not see it's not like ls/dev where you see a lot of stuff I don't understand. You just type Snap interfaces, and you see roughly the stuff you're expecting to see. I see my GPIOs, I see my serial ports, I see the hardware as it exists from like tinker point of view, not from the low level how the Linux world looks like today, tomorrow view.
And well, the gadget snap is a little boring today that we are using the PC model, but it will be really interesting next week when we have Robert talking about the Dragon board. He will explain to us about GPIO, I2C, UART, and we will have Obra talking about the Ubuntu Core side that enables people to actually use that. So come again next week if you find this interesting. I'm going back to you, Federico. You're muted.
Thanks for that explanation, Zygmunt and everyone. I think that's very helpful.
Okay, thank you. And well, we have left this with the image build, And right now we could this is a regular image that can be booted with KVM, but for being able to access this image and to initialize it, we need an Ubuntu SSO account, as Kyle mentioned before. And with this account, we are going to be able to add some SSH keys. Not the public part of an SSH key, and then from any system with a private part of that SSH key, we are going to be able to access the system. And there are no the security is the focus in Ubuntu Core. One of the main things that are that the system has been architected around is security. And well, for that, if this is this is how it looks like in the Ubuntu One page. You have one email associated with your account, and here you have the SSH keys, and here you should add the public part of your SSH key. And once this is also for what Kyle mentioned before, having this account, you are able to generate keys with a snap tool, or also I think that with a snapcraft is possible from the command line, and associate those with the same account. And then with that registered keys, you can sign your own model assertion. And not only model assertion, you can also generate and sign other assertions, like for example the system user assertion. That way you would be able to generate system users automatically, instead of how we are going to do it now. For putting this image, I have this command from the history. It's a regular KVM command. The only part relevant is this part in which we forward some ports to be able to access the instance from the host. In this case, the SSH port is forwarded, and also the HTTP port. And here is the name of the image. It's the same name that the one that we have generated. And
pretty important for testing is that snapshot article.
Of course. Using this as snapshot, the original image file is not going to be modified. So every time that we put it again, we have a fresh image and all the changes are gone. So if you don't want this, if you want to persist the changes, you should remove this snap option, of course. And well, let's execute this. I'm not sure if you are going to see much of this. This is pretty small. Here Ubuntu Core is booting. It's boot very quickly, and then being this the first boot, we are prompted in a first configuration application. It has two parts. It's used for configuring the network. In the QEMU images, it doesn't make too much sense, because the connectivity from the host is warranted. But for instance, in a Dragon board, that part would be very useful for setting up the wireless access and the access point and password and all these things. That would be one part. This first part. That for QEMU we don't do anything on that part. And there's one profile setup when we should put this one the email of one account in the store, and after this email is set, then it will contact the instance will contact the store, and then it will download the SSH, the public part of the SSH key pair that you have associated with your account, into the instance, so that you can access the device with your the private part of your SSH key. So this will be my email, and it has contacted the store and download the SSH key. So right now we should be able to access it here.
So all those news about people accessing each other's webcams through the internet because they don't change the default password, that will never happen here.
In this case, it's impossible. The security is king in Ubuntu Core, and it's all super secure. No more default users, no more default passwords, so all is super secure. So now, because the private part of the SSH key is in this system, I now should be able to SSH, and the SSH port is forwarded to this host port. So here it is. No longer apt, Ubuntu Core. Here are all the commands that we have, and this is it. I don't know if we have time to install something or try something with the interfaces or something like that.
Yeah, why don't you play on the terminal? We can keep that focused, and we can continue talking here.
Of
like
course.
You go crazy there.
Yeah, of course. For instance, we can try something about interfaces. These interfaces, well, as Michael mentioned before, all the snaps are confined. The interface abstraction allows those snaps to access some resources from the host, from the Ubuntu Core system. So by default, these are the interfaces defined. These are the resources that are exposed through interfaces. So we have also camera, Docker support, network. There are a lot of resources, and there are two sides in each interface. We have one the slot side, that is what is offered from the system, and the block side, that is the ability that have the different snaps to use these different resources. So perhaps for a snap that conveys one web server, it should use the network and network bind interfaces. It should declare plugs on those slots to be able to use those resources. So perhaps we can install one test snap. These are used by our test suite. All the snaps that begin with this test snap D are used in the test suite. This one has a web server in it.
When you type, one thing I wanna call out. The syntax, like there's colon, and then I look at maybe like network or PPP. The colon is, before the colon, you have the name of the snap providing the slot. So when the snap providing the slot is the core snap, we just don't show that, right? So it's like slot is like core provides you ALSA, core provides you camera, and so on and so forth. If you install Mir, and then Mir will provide you the Mir, I don't know, display servers, interface. I'm not sure what the name was. I think it's just Mir. But the point is that all of those plugs and slots belong to the snap. They don't like hang in the air. So maybe it's a gadget that exposes it. Maybe it's the core that exposes it. But when it's core, we just don't show it. But people are sometimes confused, what is this column thing? It's a separator between the snap name and the plug and the slot name.
Right. We don't have a lot of time left, but I have one more question. In here, Federico generated the image himself, but are we publishing already generated images that people can just throw to their virtual machines?
Yes, of course. We are. There are images generated in the. I think that I have here the link. They are in the stable channel, of course, but there are also recently images auto-generated for other channels, for the candidate at least, and I don't know if for more unstable channels, but I think that all of them are under here.
Okay, we will send you links and some instructions, some really simple, some a little more complex. And if you find something broken, talk to Federico. He's the QA lead on Ubuntu Core. He knows a lot about these things, and he's really nice. So he will appreciate all your comments and feedbacks as the rest of the team, I'm sure. Another important thing to mention is that this is command line only. This doesn't have an interface, but there are other teams here working on the higher layer. So Siga briefly mentioned Mir. That's the UI Composer server. Then on top of Mir, there's people working on Unity 8 for these images. And on top of Unity 8, there are teams working on the application. So what you see in an Ubuntu phone and what you see in an Ubuntu Classic will soon be able to just work in here in this new world of full snaps. And I think for our third session of this month, we will have the same thing, Ubuntu Core, but in a platform, probably the Dragon board, and we will show a kiosk application. So a simple UI that's full screen, something you can use for promotion on a mall or something like that, or more crazy things. You could use it as a gaming platform that has your emulator in there full time. We will try to do that that's February 16th. So any closing comments from you? No? Nobody? Everybody happy?
Thank you. It was a super nice discussion.
Thanks for coming, guys.
Us.
Lots of good information there.
Really great having you. I mean, feel free to join whenever you want. It would be great to have you around more often. So to close, Robert, maybe you can tell us about what's next for 96 boards and this great LinaroConf that's coming soon.
Yeah, I can try. Thank you, by the way, Federico, for that demo. That was really cool. I look forward to trying it out myself. I'll have to go review the video and try some stuff. But yeah. So,
and remember tutorials.ubuntu.com. Is that right? Maybe. Yeah. So that will walk you back through this.
Excellent. Awesome. Yeah. So I think what Leo's referring to is our Linaro Connect. We have a convention every 6 months, and it just takes place somewhere around the world. It's an opportunity to connect with the ARM community. People from Canonical go, people from Qualcomm, people from pretty much 80 different companies that contribute all to kind of the same cause that we do at Linaro. And again, I don't want to waste too much time on this, but you can go to linaro.org, you can go to 96boards.org, read more about this, or we can talk about it again next week during on Friday testing days. We'll be talking a lot more about this in particular. Next week, I'll be coming onto the show. I'm going to take a Dragon board, boot it up, show how to flash, basically using the instruction set that is on the Ubuntu Core website for Dragon Board 410C. We're going to flash an SD card, we're going to boot it up, and we're just going to play around with it a little bit. So get familiar with, I guess, the basic board bring up situation that you might experience running Ubuntu Core on your Dragon Board 410C. So I'm excited to try this out. I personally have not done this yet. So next week, that's going to be the fun for me. And then showing it all off to you guys will be fun for me too. So hopefully maybe everyone that's on this call could could be there in case I screw something up. So that would be.
It would be great to get your feedback too about all these things that we are doing. And well, Robert knows a lot about the board, a lot of the things that we can't answer, he will be able to answer them. So make sure to bring all your questions to Robert, and he will be with us all the month. We will be sharing sessions Thursday, Friday. It's going to be really fun.
Yeah, thank you. Thank you very much for having me. And we will share more links, I think, next episode on that because, yeah, like Leo said, we plan on having kind of merged sessions between some of the stuff we do at 96 Boards Live as well as with testing days. So hopefully we can kind of merge some stuff and all have fun and learn together. So that'll be cool. Thank you very much for having me.
Well, sounds great. Thanks for coming, Robert.
Thanks to you for coming. And we are just hitting the hour. So thanks, Federico. Thanks, Kyle. Thanks, MBO. Thanks, Robert. Thanks, Siga. I hope to see you again soon. So, bye.
All right, have a good one.
Thanks, guys.